Hi everyone, good evening. How are you guys?
Good evening, sir.
Good evening,
Everyone,
sir.
Good evening, sir.
good evening. Okay,
Good evening, sir.
we'll start the class. Good evening. So, guys, before the class starts, I would like to tell, and I like to tell, or you something, and I would like to talk to you on some very special, facts as we were discussing in the group also. See, there are some specific rules what we have fixed in the classes and before starting the internship, right? Like whenever is the class, right? The certificate and the attendance will be given only if you are attending, right? You have 40%, I mean, leverage in the attendance. That's your complete right. You can take your 40% anytime. You have to attend the 60% classes only, right? In the entire internship. I agree. I only made those rules, right? But if you are not attending and then still fighting with me and asking for the certificate and all, you cannot, right? So, see, there are multiple courses, maybe according to your convenience, maybe according to your exam schedule, maybe you are busy somewhere. I understand that you are not able to attend the classes, right? You're not able to attend any course. So why to argue for that and why to regret for that? See, if you are attending, you will get the certificate only if you are attending the course or the class, right? Otherwise, being my intern has no right to get the certificate without attending any class or any course. Okay. And there are multiple tools what we are using. We are using in Zoom, we are using the YouTube. We have all the highly paid subscription versions with us, right? Otherwise, you must have seen that Zoom comes in, 100 for some limited hours and a lot of things. But we have subscribed and paying more than 10,000 per month, almost per month, more than 10,000 just to use the tools and just to accommodate you all people with us, right? We have bought 3 Zooms, one Google Workspace entirely and you know that there are almost 30 to 35 classes every week for different courses in climate, and that's how the climate is known for. Climate and curio is known for the live classes, right? I understand that your convenience is not there always to attend the classes. I totally agree with you. I totally understand your concerns, your busy schedules, your exam schedules, and your engagement somewhere else, right? But after that, you also have to understand us. You also have to understand the rules. See, rules are very strict for the interns. See, if you are attending, you have to attend the full session. My team can come anytime and they check it. See, in my team, if you feel Dr. Samriddhi is starting, I'm starting, or Dr. Siddesh is starting, we are here to monitor. We are here to moderate. But my HR team, my other teams are always there. Digital teams are always there to check. There are invigilators who comes to the classes suddenly, who takes the entire screenshot, attendance in the Excel sheet, and they go. You know, that is manual work. But still, for your concerns, in every class, whatever I'm conducting for interns, in every class, we are sharing a Google form just to take your attendance. Okay, that is feedback form and to take your attendance, right? And if you are attending the class even 100% and not filling the form, that means you have not attended the class. Okay, remember this carefully, very carefully. So there are some rules. You have to be disciplined for some things. See, if I am doing a lot of things, then you have to understand. And then see, I'll come to the DIT course only, design thinking and innovation part in pharma. That was not conducted by me. That was your idea, guys. Come on. That was the idea of my innovation team, innovation club, right? Was that my idea? No. I have a lot of other ideas too. And literally, guys, I have holded back many courses. I have holded back CCMC. Even my team was telling, sir, let's launch CCMC because, people, lot of other people are asking for CCMC course. Lot of other people are asking that we have not conducted the ICH GCP guidelines training for outsiders. We conduct every month. But why I'm holding those things back? Because I want you guys to be fully involved and learn from them. And I know that April and May are the months for exams. You know, that's why I'm holding back a lot of things. I know you guys are busy in exams. I know, one or the other university has exams in these months, right? That's why I've asked you for the exam schedules. So your lot of things are pending from my side. But other than that, also, I'm trying to conduct a lot of things. See, we have conducted LinkedIn class, we have conducted entire innovation course, which is unique. Even I have learned a lot. I was seeing the recordings later, right? This was one of the wonderful course, and this is one of the thing, the corporate people asked for. We conduct such trainings in the corporate setup, and here I'm conducting for my interns. See to what level of learning you are getting it. Getting here, and that is without charges, right? And I'm concerned about you only. I'm not concerned about something else or anything else or anyone else, right? I have called Dr. Mahendra Singh Rathore to conduct these 3 sessions on the holistic approach, where you will be learning all about procrastination, how to resolve the procrastinations, and time management, and a lot of things about students, right? I have called, our uh, the mentor for stress webinar, right? And I'm very much happy with the clubs, that these clubs are doing wonderful. See, innovation club is coming up, every day they're coming up with ideas. They're coming up with the research cafe. That is for you to learn. They're coming up with lot of mentors. I think they have already fixed 5 mentors, 5 people for the research cafe interview, whom for whom they're arranging these things for you only, right? So you have to show a little enthusiasm to attend those fully and be in discipline by filling the forms. If you are not filling the forms and attending the entire session, entire course, I'm so sorry. I'll not be flexible here at all, right? So if you are coming, please attend till end. It is not just to show off. See why I'm investing my time on you guys, why I'm investing, why I have started this course again, why I have started this entire internship all again after 2 years, and not charging anything again. If you see other people, they are charging a lot. If you go to the industry, a lot of things are there, and I'm conducting it 100% online. I'm not asking anything from your side except your attendance. Yeah, what I take from your attendance, guys? Tell me. If 10 people are coming or 100 people are coming, what I have to do? It's okay, fine, let it be. What I have to take from your attendance? Nothing. You have just paid me 999 rupees. That is less than 1,000. I mean, just 1,000 rupees you have paid me for 6 months, right? You have just paid me 1,000 rupees for 6 months, and that is also refundable. So why don't you be in the discipline? Tell me. I can send any of my teammate to teach you statistics. Dr. Siddesh is there. Dr. Samriddhi is there. There are many other people. I can call the people from outside. They will teach you the statistics and go out, right? Why I am teaching? Because I want to teach you. See, that class, what I am taking today, and I'll be taking even tomorrow. Why I'm taking 1 hour class in 3 hours? Because I want you to understand. I know how the pharmacies and pharmacy practice people and B farm people, how the pharmacy people, they have literally no knowledge about these things. And nowadays, skills are very important. I want you to get developed professionally and personally. That is my only agenda. And I just want one thing, that is your attendance, your full enthusiasm to attend the course and being in the discipline. Suppose I'm telling you, right? One example, and then I'll start the class, right? I'm asking you one thing. I got many personal messages also. Okay. I got many personal messages after these arguments in the group. Sir, this is not fair. Sir, uh, we have attended all 3 days. I forgot to fill one form. Okay, just one example. You have to tell me. Okay, you have to answer this. See, if you are going to the office, you are in the corporate setting. You have to punch in and punch out. You are going to the office, but in a month, 5 days, you are not punching and punching out by your card. Will you get the salary of those 5 days? You go, you do your 100% work, do your 200% work, stay entire day and entire night in the office. But if your attendance is not, punched there, you will not get the salary. You understand? So that doesn't mean that you have not been in the class, or I mean in the office. But this is about your discipline to punch the card. Okay. So here also you have to learn the punctuality, you have to learn the discipline. That is my concern out of filling the forms. So I'm so sorry if you have not filled the form, your name will not be in the list, right? So with that, guys, thank you very much, right? And if I'm understanding you, you have to understand me as well. Okay. So let's start the class, guys. I'm sharing my screen and you just confirm it. Okay. Yeah. Yes. Okay, so guys, till date, in the last class, only one class, we have talked about the data types, right? Like we have, can someone revise me how many types of data I told? I forgot, guys. Can someone tell me how many types of data I told you? Data types? Can someone revise? Yes,
Two types.
Two types, sir.
two types, quantitative and qualitative. In that, there was something in the
Ordinal, nominal.
ordinal nominal, in the quantitative, and in qualitative. Okay, it was in quantitative or qualitative?
Continuous and discrete.
Continuous and discrete in are the part of
Quantitative.
Quantitative.
quantitative. Yes, and nominal and ordinal are the part of qualitative data. Absolutely fine, right? One more question. If we have two variables, only two groups, then what is called as binary, or there was another name. There was another name. There was another name. Dichotomous. Absolutely dichotomous. Okay. Now give me the three examples. I think we have discussed about the central tendency also. Give me the three examples of central tendency.
Mean, median, mode.
Mean, median, mode. Fantastic. Let's quick revision of the class. Now let me tell you furthermore, after mean, mode, median. And see, when we write a mean, you must have seen in many places. See, first of all, that rule is there that if we are using mean, the data must be continuous, right? Data must be continuous type of data. If we are using median, data could be continuous or could be qualitative, ordinal, or maybe nominal also, doesn't matter, right? So if we are using mean, you must have seen like there are certain examples. Age. So if I say that you have to write the average age, you will be writing, right, okay, 59 plus minus 17 years. If I'm asking what is the BMI, you will be writing, okay, the BMI of the group was 20 plus minus 20, let's understand 28 plus minus 8.5, right? Kg per meter square. Correct. So can someone tell me what does it mean? 59 plus minus 17 years. What does it mean? Can someone tell me? I don't want to know that this is standard deviation. I don't want to know that. I know that this is standard deviation. You guys know that if we are writing here something after plus minus, either, that could be either SD or that could be SEM. What is SEM, guys?
Standard error of mean.
Standard error of mean. Perfectly fine. Standard error of mean. Yes, absolutely. Standard error of mean. Right. Completely fine. Now, tell me what does it mean? 59 plus minus 17. One group has the age of 59 plus minus 17 years. What does it mean? Range of what? What range? Lina and Dharani, what range? Vaishnavi, yes. Range, but what range? Deviation. See, it is simple. It is very simple to understand, guys. See, the range here is, what does it mean by range? See, if I'm writing here 59 plus minus 17 or whatever we were writing, right? So it does mean that the age is 59 minus 17 to 59 plus 17. Understand that? So 59 plus 59 minus 17 is 42 to how much? 76. So the age range of that group is 42 years to 70 to 76 years. The person in the group had this age range. Okay. This age range, 42 years to 76 years. Right. And in between, whatever the number is. Right. Whatever the number is. If I'm telling that it is like 8.5. So the BMI is from 28 minus 28 minus 8.5 to 28 plus 8.5, right? So from where to where? From 36 point, 36.5, from 19.5 to 36.5 kg per meter square, right? This is that meant. But why we need standard deviation? Can someone tell me why we need standard deviation? Why we need standard deviation? Can someone tell me? Yes, guys. See, the answer is on the screen. Measurement of variation or dispersion. See, when I'm asking the percentage marks of a class, you will be saying, sir, it will be, like 72%, plus minus 5-6%, whatever, plus minus 13-14%, whatever you are telling, right? But why? See, if I'm telling that, like if I can tell, I mean, I can also tell you 75%, 72% is the average marks, correct? But if I'm adding plus minus 13% also, that means I am, clarifying more. I'm giving more idea about the dispersion. Dispersion means how my class has the diversity in the marks, right? How my class has variation in the marks. I have the person who is less than 60% also. I have the person who has 85% also, right? So it shows the measure of variation. It shows the measure of dispersion. Dispersion means that every individual value is different. State, okay, right? Not that statement. In any group, every individual value is different. So measures of dispersion means you are measuring all the values and showing that in one precise result, right? So we show the mean with or without, what? With or without standard deviation or standard error of mean. So let's understand what are the measures of variation or dispersion. See, there are 5 leaves. Okay, there are 5 leaves. Okay, there are 5 leaves, guys. You can see here. So can someone tell me, is the perimeter of all the leaves same?
No, sir.
No, sir.
Read the question properly.
Same, sir.
See, that is where you guys have to understand statistics. See, the perimeter is what? Perimeter is the distance
Same.
or the length, this length. Okay, this length, right? Is same. It is same for all 5 leaves. Okay, the perimeter is same for all 5 leaves. The only difference, or if I say the only similarity here, is the perimeter. And you can see multiple differences. Difference number 1, size. Difference number 2, shape. Difference number 3 might be the type of tree, right? Type of what we say it, type of distribution, what we say it. I forgot that the botany term for distribution of uh, whatever it says, right? There are differences, but there is one similarity, that is perimeter, right? So we have one similarity but major differences, right? So if you come to the statistics, a lot of people in last class, they have asked me, right? They have asked me like, sir, give some examples from the medical or pharmacy background. Let me give you one example here. Okay, see, you are doing a study on, suppose, diabetes patient. Okay, diabetes patients, right? So in diabetes patients, you are checking the efficacy of metformin. So how would you check the efficacy of metformin? You will be giving metformin to group A and you will not be giving metformin to group B, right? That is, you can understand, this is case, this is control, right? So the similarity here would be, suppose 75 participants, 75 participants. This is the similarity. This is the similarity. So you cannot judge them. If I'm asking the age of these 75 and then 75, you cannot judge them by the number. Oh, this is 75 people and 75 people, so might be same only 60 years, 60 years. Not at all, because every individual have the different variable age or whatever variable we are taking, right? Everything is different. Maybe only one similarity, but other things are different. So to check the individual differences, now write this statement to check those individual differences. Okay, on the big picture, we do the dispersion check, right? We do the dispersion measurement, and dispersion measurement can be done by these things. One is variance, which is very simple. One is standard deviation, then coefficient of variation, then standard error of mean, then range, and then interquartile range, right? IQR we call it. So today we'll be learning about these things: the variance, standard deviation, coefficient of variation, standard error of mean, range, and interquartile range, right? So let's go ahead one by one. So first thing here is, look at this, guys. The example, as I was telling, height of the students in feet. All right, in feet, the student's height, first farm D, if you check the mean, okay, first farm D and fourth farm D, if you just look at the mean of age, I mean mean height of the students, exactly similar, mean age of the students of first year and fourth year is same. Even the bloody median is same, 5.5. Even the mode is same, 5.5. Even the mode is same, 5.5, right? 5.5. Now guys, if all the central tendency measures, are same, can we say that these two classes are same? These two classes has the BMI same. Can I say that? Can I say that these two classes has the BMI same? Can I say that these two classes has the weight also same, because their mean, median, mode, height is same, is similar? Can I say that?
No, sir.
Only one answer here. No, I cannot. Why? The example is in front of you. Look at this. See, 5.4, 5.6. Student number 1, 5.4 versus 5.6. 5.8 versus 5. See, if I look at these numbers only, see, 5.4 is unique in this side, first year family, right? 4.8 is also unique this side, right? 5.9 is also unique this side, which does not match from this side, right? 5 is unique this side, right? 5.6 is unique this side. 5.7 is matching here, okay? 5.7 is matching, 5.5 is matching, 5.7 is matching, suppose 5.2 is matching, suppose. Then see, all others are different. 6, 5.5, 5.5, suppose. Okay, so 6 is where you know, it's varies here. 4.2 is varies, 5.8 is varying, I mean 5.8 is matching, 4.9 is vary, 5.1 is vary, right? So there are individual variabilities, right? There are individual variabilities in all the individual participants. Suppose I'm taking another case. In my study, I'm taking 50 South Indians and 50 North Indians for the study. I'm not differentiating, but I'm just giving an example, right? 50 South Indians, 50 North Indians. I'm checking their weights, I'm checking their heights, I'm checking their BMI. Average BMI, height, weight, everything is similar. Does it make them exactly similar in patho or physiology or in the disease development or in the treatment patterns? Does it make it same? Does it make it similar? No. Why not? Because see, the food habits, the geographical conditions, the living status, lot of things are different. And that comes education, that comes on the individual basis. And that's how we need to calculate the variance to understand those differences. The bigger differences are checked in mean median board, but there are some individual differences which we have to check by variances and dispersants. So let's go to the next slide. Variance. What is variance and standard deviation, right? So variance is a simple formula. Variance is nothing but the measurement of individuals around the mean. Okay, individual measurements of the data around its mean, okay, for the distribution. How the data is distributed around the mean. Remember guys, how the data is distributed around the mean is known by the variance. And variance is the standard deviation. When we take under square of the variance, that is called standard deviation. Okay, so the formula is very simple here. X minus x bar. Okay, x minus x bar is what? See, x bar X is the variable here, individual value here. Suppose I was writing the height 5.5 and 5.68, 7.2. These are the heights. These are individual values. These are individual values. Okay. And X minus is mean. Mean of these is X bar. Sorry, not X minus, X bar. So X is individual value and X bar is the mean of the group. Okay. Divide by n minus 1. Divide by n minus 1. This is the formula. N is the number of individual values in the group. So when we just square it, okay, epsilon, I mean the cumulative we take for everything. Okay, cumulative means all the individual values, we take this and divided by this, that is called variance. Variance is known as S square, where S is nothing but the SD, standard deviation. So if I want to take S, it will come like epsilon X minus X bar, which is written here, divided by n minus 1 ka under root. Okay, sorry, x bar square ka under root, right? This is the simplest formula to check the mean and SD. So mean is important to understand the standard deviation here, right? Mean is required. Now let's see how to calculate it. See, here it is given clearly. This is the individual values. There are the 7 numbers. There are the 7 students in the class. Let's understand the students and their marks in assignment out of 20. Okay, out of 20, their marks in assignments, right? So 8 is individual value, 5 is individual value, 4, 12, 15, 5, 7 for these 7 students, right? Now mean for this is 56 minus 56 divided by 7. Mean is 8, right? X is this, X bar is 8, right? So how the next thing will come, X minus X bar will come like this, 8 minus 8, 5 minus 8, 4 minus 8, individual values minus mean, right? Individual values minus mean, 12 minus 8, 15 minus 8, 5 minus 8, 7 minus 8. Now we have to square these values, whatever is the result. So 0 into 0, 0, 3 into 3, 9, minus will go away. 4 into 4, 16, 4 into 4, 16, 7 into 7, 39, 49, 3 into 3, 9, 1 into 1, 1. Now, what next we need for the formula is epsilon x minus x bar chi square, that is 100, right? I mean, completely 0 plus 9 plus 16 plus 16 plus 49 plus 9 plus 1 is equal to 100. Right, now SD will be 100 divided by 7 minus 1. So 100 divided by 6 is equal to 16.67 under root, right? And that is 4.08. So SD here is 4.08. Now how will we write 8 plus minus 4.08? This is your SD and very simple formula to calculate the SD, standard deviation. If I want to know the variance, what will be the variance? Variance will be 16.67 here. We don't do the end, we don't do the under root here, right? So it will be 16.67 and the SD is 4.08. Now let me clarify, this will not be calculated by hand at all. If you are going to the exams in 4th year, 5th year or B.Pharm people, definitely they will ask such questions and you have to do it manually or with the help of calculator. But in real research, you don't have to use your manual power to calculate these things, because everything is very much available in the in the tools like SPSS and all. It is just one click away, whether you have 1,000, 10,000 or 1 million variables or 1 million values, it will be calculated in fraction of seconds, right? But it is important to understand the basics. Now let's understand, SD is very useful measure of scatter of the observations. Scatter of the observations means it will tell you how widely your values are spreaded, right? As we're talking about is, so like 42 to 75 years, right? In that example I've given, right? And then merits, it is rigidly defined based on all observations. So we need all observations. It is suitable for further mathematical treatments. Further mathematical treatments means like confidence interval, SEM, that's here. Okay, that's here. Further in there. So coefficient of variation is the next thing to understand, guys, what is coefficient of variation. So coefficient of variation is nothing but it is the, like, as SD expressed, it's kind of percentage of mean. But when we are comparing, so coefficient of variation is known as the relative SD. Okay, relative SD. Okay, relative SD, or this is the independent measure for the percentage of standard deviation. Standard deviation का percentage, it is the percentage and the relative measure of variation or mean, or we can say the standard deviation का relative mean. Okay, so how we calculate it? Simple formula. Confidence, coefficient of coefficient of variation is nothing but SD divided by mean into 100. So it is, we can say in the simple terms, if you don't read the texts, percentage of standard deviation. Percentage of standard deviation is known as percentage of non-standard deviation, percentage of mean. Okay, percentage of mean is called as coefficient of variation, CV. Okay, percentage of mean, or we can also say the relative measures for variation or relative measures for standard deviation. Okay, so that is coefficient variation. You don't have to, what we say, you don't have to calculate it, and it is not used everywhere. See guys, coefficient variation is not CI, that is confidence interval of 95% or 90%, what we say. Coefficient of variation is not confidence interval. Remember that, don't get confused. Okay, confidence interval is the confidence on your errors, or confidence on your originality of the data, or confidence on the accuracy of your data. That is confidence of interval. This is coefficient of variation. We usually don't use coefficient of variation because this is nothing more than standard deviation or mean. Okay, because this is the percentage of mean only, right? But if you want to understand, you can write, if somebody asks like to write in two numbers, 2 marks, 3 marks, you can simply write this is the relative measures of variation or standard deviation. This is also known as percentage of mean, and this can be compared, or this can be like calculated by standard deviation divided by mean into 100. Right, now the major thing comes here is standard error of mean. First of all, why we need to check the standard error of mean? Why? When we have standard deviation, then why we need SEM? See, sometimes, as in last example I showed, that mean, median and mode, all three are same. I showed that, right? And standard deviation was different. But sometimes guys, sometimes even the standard deviation is also similar. In certain cases, standard deviation is also similar. This nobody will tell you. I'll tell you why we check SEM. There are certain facts. First of all, when SD is also same between two groups, two or more groups. I mean, we check the groups, right? Between groups when the SD is also same. The second thing to check the SEM is when SD is more than 50% of mean. In that case, we usually go for median. But if it is considered to be more than 50% of the mean, for the better representation, we go for SEM. We go for standard error of mean. And standard error of mean shows the precision, precise results. More than standard deviation, standard error of mean is precise. Okay, so we go for SEM in certain cases. So SEM, or standard deviation of the mean, standard deviation of the mean is measure of the variability of the mean. Even there are the variabilities in the mean, based on the standard deviation. So we go for SEM, and it is very simple to check. See formula. SEM is nothing but is equal to SD divided by under root n. Okay, it's very simple formula. SEM comes from the SD. So even the individual values are clarified, checked. Okay, so based on SD, we check it, right? So how we write it? Like this, mean plus minus SEM, as we write for standard deviation. Similarly, we can write for standard error of mean. Got it, guys? Okay, any questions till now? If not, then we can go for the further things. Range. What is range? Range, you know, guys, what is range? X minimum, X maximum to X minimum, as we have seen. It is very simple. X minimum to X maximum. That is the range. Like I was talking about the age, I was talking about the marks. So whatever is the minimum to whatever is the maximum. Suppose we were talking about the age. So 42 to 75. So what is the range here? What is the range here, guys? Range is nothing but the 75 minus 42. Okay, that will be 33. 33 is the range here. Here the range is 33. 33. Okay. The 3. Sir, can you please explain the 3, that is variance, standard deviation? Okay, with one example. Definitely. I'll explain. No worries. Okay. So we were talking about range, right? So as they have given the example, 122, 130, 128, 119, 123. So maximum is 130 and lowest is 119. So 130 minus 119 is equal to 11. This is also the simplest measure of dispersion spread. We can say, okay, our population is spread from here to here, right? From here to here, one range to another range. One individual value to another individual value. That is called range. Now, why it is not used? Because it is not based on the all observations, right? Range is not based on the all observations, so we cannot take range. Maybe there are, like here, suppose 100, then 198, 198, 199, 199, 200, 201, 202. These are the values. So what will be the range? 100 to 202. So what will be the range? 102. But actual values are from 198 to 202 only, maximum. So it will not be helpful in understanding the entire observations. This is just for two observations, from the first observation and the last observation, not for the all observations, guys. And it is very much affected by fluctuations of the sampling. Exactly. Like if one value is only 100 and others are 198 to 202, then it is completely fluctuated. We are countering like 100 to 202 is the range, isn't it? So it is fluctuated. Now, as you have asked me to give the things about variance, standard deviation, and see, first is variance. So variance is also talking about dispersion. How to check the variance? S. Variance is S square. Okay, variance is S square here. And suppose, there is one, there are two groups, A and B, right? So mean, mode, median. Mean, median, mode. So mean, median, mode, right? So mean, median, mode are like almost similar. Almost similar. So now we will try to understand the dispersion between these groups, because all the individual values will not be same. As we know, in any group, there are no similarities. In individual values, there are no similarities. Only maybe the averages, like mean, central tendency, would be same, but individual variances will be counted by the dispersion measurements only. And how to calculate? First thing is variance. This is major. So how to calculate it? Like first, we take for all the measurements, we check the mean and we get the square of that individual values, and if we take all the values divided by n minus 1. This is the formula. This is the formula of variance. And this is the same formula for standard deviation, because standard deviation is nothing but the under root of this entire thing. Okay, under root of this entire thing, what we say the variance. Okay, n minus 1. This is the standard deviation. Okay, this is the standard deviation, and standard deviation also shows the measures. But this is the first thing. I mean, the variance is first level. Then we go to the standard deviation. Variance is level 1. Standard deviation is upper level, level 2, and then it comes the SEM, which is level 3. Like, if the variance and standard deviation is also similar, you can check SEM. SEM, how the SEM is checked? SEM is checked very simply, like mean divided by n under root. Sorry, SD divided by under root n, right? Isn't it? This is the formula, if I'm not wrong. Yeah, SD
Yes,
divided
sir.
divided by under root n. That is SEM, right? So this is more precise. If you want to go to precision, you have to check level 1, that is variance, level 2, that is SD, that then SEM as level 3. So first, if SD is perfect, then no problem. If the variance is different, no problem. If these two are also similar and not meeting the conditions of 50% or more, we can directly jump to SEM. Okay, standard error of mean, right? Okay, guys. Yeah. If sample size is less than 30, then we use n. For more than 30, then we use n. No, there is nothing like that. There is no formula like that. Not at all. Okay, why that minus 1 is denominator gonna play a role based on the sample size? Okay, now let me tell you how this n minus 1 is gonna play an important thing here. You remember when we were checking what median? Remember median? How we were checking the median? One sec, guys. One sec. Yes, guys. So I was talking about that only, right? So when we were, why we check the median, there is like, the what we say it, when we were checking the median, we wanted one value. That value was middle value, right? That value was middle value. And how did the middle value came, right? How did the middle value came? Like if the number was odd, that has come after the total number of the values minus 1 divided by 2, right? Divided by 2, correct? So it has linked with that. It has linked with getting the middle value, getting the central tendency. Okay, it has no specific reasons, frankly, but it goes with getting the central value, getting the middle value to check all the variations in the entire population. Okay, entire population we need to check. So this concept has come, like if the odd or even whatever the thing is, we will get the correct precision value. There is no specific value from that. Okay, I'll check if I get something. I also never thought of like why the denominator is minus 1 and minus 1. Okay, but I'll check it for you guys, right? But that concept has come from that, to check the when we usually check the median. Okay, but why for population SD we use n, but here n minus 1? No, for the population mean SD also we check n-1 only. SD is calculated by this number, calculated by this formula, right? And see, if you're talking about n, small n and big N, there is nothing differences. There's nothing much difference, you know. Usually when we have the entire population and multiple groups, so each group has n number and the entire population has n number. That is the logic behind capital N and small n. Okay, that is the logic behind capital N and small n. Okay, nothing much in that. Okay, now let's come to the next thing, that is interquartile range. Okay, now that is interquartile range. So guys, when we talk about interquartile range, what exactly is interquartile range? Again, let's go back to mean, median and mode. Interquartile range comes with the median. Okay, now let's understand this. Let's understand this. There is 100% population, right? There is 100% population. Let's divide it into 25%, 25%, 25%, 25%, right? First 25% is Q1, Q2, Q3, Q. There is no Q4. There is maximum or minimum. Q1 is minimum, Q4 is maximum. Okay, so guys, how and how it exactly works. Now look at this. Let me delete all and let me show you once more. See, this is the central tendency. Okay, this is the central tendency. Okay, and this is the entire population. This is the entire population, 100% population. Guys, how it works, how it works. As I was giving you the example of 10th class, maybe some scattered values are there, right? Maybe some scattered values are there, but not all. So if you look at the central tendency, majority of the values will be here. Okay, nearby, here and here. See, what's the big difference? So 25% will be just near to the central tendency. Then 50% also will be near to the central tendency. And then other 25% will be scattered and other 25% will be more scattered. Okay, so that's how we check and divide our population into quartiles. That's how we divide our population into quartiles. How we divide, like, okay, 25% is very near, that is Q1. When this comes to 50%, total 50%, okay, so including Q1, Q2 is including Q1, remember that, including Q1 is Q2. Okay, so total 50% is called Q2, right? And this is also near to the central tendency, and that is called as median. Q2 is also known as median, right? Median is nothing but the near central tendency, or one of the factor, one of the measurement of central tendency. Okay, so you understand that Q1, Q2, Q3 and Q4 is the final maximum. When we go and check the median, suppose I'm checking the mean here, guys, right? I'm checking the mean here, plus minus 17 I checked, right, years. If this is not working, if this is not working, if it is like more than 50%, or there are the things where I cannot use the mean, I have to use the median in such cases. So if I'm checking the median, so what it will be, like 59 years here. What I'll be right here? I'll be right 42 to 75 years. This is Q1, this is Q3, this is Q2. So Q2 will come out, Q1 and Q3 will go in. Okay, this is Q1, value of Q1, this is value of Q3. Okay, and this is Q2. So that's how we write our results with median, like 59, 42 to 75. This shows the range also. This shows the interquartile range. So within the quartile, between Q2, between Q1 and Q3, there is Q2, that is called median. Understand that? That's how we go for the interquartile range. Interquartile range means how dense it is. So always, guys, always understand Q1 and Q2 will be having the maximum density of the population. Maximum density of the population will be with Q1 and Q2. and then it goes up to Q3. That's why we take the range from Q1 to Q3, and Q2 we write outside the bracket, that is median. That is one of the central tendency. Okay, so I hope you understood that. If not, please tell me. Okay, can you please repeat the difference between N and N? Nothing, there is no difference. See, if I'm taking like in one village, you are taking the entire village for vaccination. You are taking entire village for vaccination, right? The population of the village is, suppose 10,200. This is N. The population of the entire village, population of the entire group is N, right? Now, if I ask you how many people are male, how many people are female, so N is the number of participants in stratified groups in the big population, right? Group A is N, population of group A is N, population of group B is N. So there is always the debate. If you are going for the standard deviation for the entire population, it will be N, big N. If you are going for the SD for small, that is N, right? So there is no specific definition where to use which N, but how we take big N and small n is like stratified groups always have small n. In big population it is capital N. But when we check SD and all, like for the entire population also, we write N, right? That is small or big. It doesn't usually matter much. Okay. Yeah. Now, this is the thing what I was telling. So 25% is the first quartile, most dense. Second quartile is also known as median. Third quartile is the upper quartile. Nothing much. Now I'll come to the confidence interval. Okay, that is again one more thing. So guys, just give me 1 second. Yes, guys, I'm back. I just had to. Okay. So here, okay, here we'll be talking about the confidence interval, guys. Okay, confidence interval. Let's talk about the confidence interval here. Okay, there are some questions. So can you repeat the quartiles concept briefly? See, I have, okay, so can you briefly quartiles maximum density? Please explain again. Okay. When we apply IQR, median or IQR representing non-parametric data. Okay, wait, I'll tell you, I'll clarify. You have a lot of doubts. Okay, you have to think of that in a nice way. Okay. Okay, so you didn't understand the Q1, Q2, and Q3 concept. Okay, see, central tendency. Suppose, again, I'll give you the example, very simple example of 10th class. Why I give the example of 10th class? Because it's very simple, right? Such 10th class is 15 years old according to the law, right? By the rule, it is 15 years. But there are some people like 12 years, 13 years, 14 years, 16 years, 18 years, 19 years, 21 years, 21 years also. Suppose let's take, right? So here 15 years is the central tendency. Central tendency, right? If there are 100 students in the class, about 80 will be around 15 years of the age, then 20 will be scattered, right? Or maybe suppose that 30 will be scattered, but most of the population will be near to central tendency, right? So this is the central tendency here, and the most of the population will be nearby, that is called as quartile 1, right? 25%. So 25%, first 25% population will be very near to the central tendency. This is very dense area, Q1. Q2 again will be a bigger area than Q1 because the 50% of the population again will be near to the central tendency. So this is also very dense. and 50% of the people or participants are here. That's why it is called as median. That's why it is called as median, right? And now if we come to the Q3 or Q4, those are very big areas. Like those are scattered individual variables somewhere, scattered values. Not all the values will be here. See, for 25, first 25%, only a limited area. I mean, I'm just telling you according to the area density, right? So most of the first 25 or 50% population will be very near to the central tendency. Okay, very near to the central tendency, right? And then others will be scattered and will be in the more coverage. More coverage means the extreme values, outliers, or the different than the central value. Understand that concept, guys? I hope it is clear. So Q2 is measured as median. Okay, now there are some more questions. Median and IQR where we apply. See, first of all, we apply, don't go to IQR. Okay, don't go to IQR first. Let's understand where we can use mean and where we can use median. So wherever we are using median, we have to go with IQR. You understand that? Median or mean always goes with SD or SEM. Similarly, median always goes with IQR. So that's how we use it. That's how and that's where we use it. Remember, guys. Okay. So mean plus minus SD, median is IQR. So if I'm writing here median 59, 42 to 75 years. So here I'm showing the Q2 like the central tendency, major central tendency. Then Q1 to Q3 is the range. Q1 to Q3 is the range, right? That's how we write. Exactly, this is not the range, but this is covering the maximum population. This is covering the maximum population with the median. Understand? That's where we use interquartile range, and that's how we use median. So where we cannot use mean, like if the mean, like suppose if I'm writing 59 plus minus 30, I should not use this mean with SD. Why? Because the scattering of the data is too much here. If it is crossing more than 50% of the mean, if the SD is more than 50% of the mean, we should not go for the mean, we should go to the median, right? If this is having many missing values, remember in the first class I've described, if we have a lot of missing values, we should not be here, we should go to the median. If the data is qualitative, not quantitative, if data is not quantitative and data is qualitative, we should go to median plus IQR. Median plus IQR, not the mean. Understand that? Understand the difference, guys? I hope you understood. Sir, by using IQR, can we find scattered data? This is the representation of the entire data. Yes, you can. You can tell the range. If you're writing the IQR, you can tell the range. But if you have the mean with valid SD or SEM, no need to go for IQR. Right? No need to write. So there are some rules. If you are using the mean and data is valid or normally distributed, we do not have to go to the IQR. If data is scattered and the standard deviation is not following the rules of mean, like more than 50% or the missing values, and the data is qualitative, in that case, we go for the Q2 or median, right? Formula should be no. We are writing the range, Samita. We are writing the range. So the formula here is not what you are telling. Formula here is Q2 and range would be Q1 to Q3. Here we are not deducting it. We are not taking that. We are not deducting it. No, we are just simply saying that minimum to maximum. We are saying the range minimum to maximum. So Q1 to Q3. Okay, we are not deducting it. It is just a showcase. It is just to represent the population. Understand? Okay, now let's come to the last question, term of the central tendencies or the dispersion is confidence interval. Confidence interval is not actually quite debatable point, because confidence interval exactly does not mean the central tendency or the variation here. Okay, it does not mean the variation. Yes dear, upper value is q3, but here we are not deducting, here we are showing from minimum to maximum. This is the range we are showing, we are representing the data, we are representing the data. When we are representing the data, we do not go in the ulta way, we don't go in the ascending way, we go always, we don't go in the descending way, we always go in the ascending way from first q1 to q4, because q1 is the more dense part. Okay, now confidence interval is the fiducial limit, we say it, or this is the statistical significance. So confidence interval always go with the significance. Okay, it does not go with the, what we are reading here is measurement of variance. Okay, it does not go with the measurement of variance, it goes with, always goes with the confidence or the significance, difference of significance. Now let me give you the example. Okay, see, 95% confidence interval, 95% confidence interval, what does it mean? Okay, so it is like range within which 95% of the mean values are likely to fall if determined in the similar experiments. Simple thing, if you correlate with the central tendency, if you correlate with the measurement of variance, right, measurement of variance or dispersion, it simply says that it is expected that 95% of your individual values fall in central tendency, fall in central tendency and having the normal distribution. This is the actual meaning of 95% of the confidence interval. You understand that only 5% of the data is supposed to be scattered as the extreme values or outliers. Only 5% of the data. In another word, the confidence interval of 95% says that we are 95% confidence on our data, that our 95% of the data is falling in place as no error. Error here means the extreme values or outliers. Understand that? Very simple to understand. 95% confidence interval, why do we take it? Because we are confident, we are assuming that our 95% of the data is normally distributed and rest 5% can have the errors. You understand that? That is the very simple thing to understand about the confidence interval. Confidence interval, if you have to write 5 lines about confidence interval, simply you write, so it is a statistical significance of the range of true mean. And we can say that we are 95% confidence that our mean will fall in place, or our individual, our values or our data will be normally distributed and fall in place. Right, so you don't have to understand the formula, but this is the formula. 95% CI is calculated with mean plus minus 1.96, that is coefficient. Okay, SD divided by N. So simple is like mean, okay, plus minus 1.96 into SEM, 1.96 SEM, we can write this. Okay, confidence interval 95% is nothing but, guys, look at this, very simple, I'll make it very simple, mean plus minus 1.96 of SEM. This is the confidence interval. Okay, and we are very confident about the data, but now there are some specifications, there are some problems, like in many studies, in many big randomized control trials, where we get more realistic data, we get more realistic data and we want more specific results. Sometimes we just take only 1% of the errors. In that cases, CI is 95%. Okay, CI is 99%. So we are assuming that our 99% of the data will be falling in place. Okay, 99% of the data. Now it correlates with the p-value also. If the confidence interval is 95%, that means your errors are 5%. So 5% is what? Of 100. It will be 0.05, right? So your error is supposed to be less than 0.05. Your p-value should be less than 0.05. Difference between groups for error must be less than 0.05. And when we are just talking about 1%, then your p-value must be what? 1% divided by 100. If I say 1 divided by 100, less than 0.001. I mean less than 0.1, right? It should be less than this. And sometimes we take 90%, sometimes we take 80%. So when we are taking 80% of the confidence interval, that means we are not confident on 20%. So p-value will be 0.2. Okay. And error, margin of error will be 0.2 in our data. You understand that? That shows the realistic way of the data and how much data you are expecting to fall in place, guys. Okay, you are expecting how much data to fall in place. That depends on you, but mostly it everywhere we use 95% of the confidence interval. That's why I'm talking about 95% of the confidence interval. What is 9 point? That is constant coefficient value. That is constant. This is like as we have the value 3.516444 pi, you know, right? Similarly, we have the coefficient here. Coefficient means the constant value. It will not change in any condition. So here we are just taking 1.96 of SEM. So that means around twice of SEM. If I say around twice of SEM, so 1.96 is the constant coefficient. Okay, so with that, that's okay, guys. And tomorrow we'll be talking about the parameters. We'll be talking about the non-parametric test and parametric test, and then we can start the what? We can start the SPSS from the next Wednesday with Dr. Siddesh. Okay. So guys, this is the time. This is the time for what? This is the time for your questions. Please ask your questions. If you have any questions, please ask your questions, and don't forget to fill the form. Don't forget to fill the form. Here is the form. Form is here. Everyone has to fill the form. Yes, everyone has to fill the form. Form is here. Okay. Tomorrow we'll be talking about the tests. Important class, guys. Tomorrow again we'll be talking about tests. What type of tests, where to apply. Okay. Yes. Yes, 195, 1.96 is Z value by using the Z table. Exactly. Zeta table, we call it Z table. Yes, that is the 1.96. So it was little difficult to catch up with Q1 and Q3 details. See, this is nothing simple. See, how again I'll tell you one thing. See, suppose I'm going to your class Farm D. Let's take your class only, right? Let's take your class only, Farm D, 5th year. What will be the average age of your class? Can someone tell me what will be the average age of Farm D 5th year or B Farm 4th year? See, Farm D 5th year, it will be like maybe 21 or 22.
So 23.
22 or 23. Yeah, suppose 22. Let's take it 22, right? 22 years is the Farm D 5th year. But it's not necessary that everyone is 22. But there will be maximum people who are having 22, right? So we divide the entire population into 100%, right? Like, okay, first 25% has how much average? 22. First 25. Central tendency, we got mean. We got the mean, right? Central tendency, we got the mean. or median, whatever is there, we got the central tendency, one value, one middle value, 22. Now we'll see first 20 nearby first what is around 22. So you will see that out of 60 50 out of 30 family fifth year, there are 25 who have 22 years old, who are 22-year olds. So more than 50% will be just around the central tendency. That's why I'm telling Q1 and Q2, like first 25% and second 25% will be very near to the central tendency dense population. And then 75%, next 25%, I mean the total 75% is Q3. Okay, so Q3 also in that case will be very near, but maybe far in certain cases. But the last 25% will be definitely far away. Maybe there are 21, there is 27, there is 28, there is 20, right? So that's how we take it. And when we are writing the median is also central tendency. Median is also central tendency. So 22, and then we write minimum to maximum. No, minimum to maximum is range. Here, interquartile range. Like the first 25% to 75%, and then 50% we are showing that, okay, this is the marginal maximum. This is the marginal maximum to represent a group. See, first thing is mean. If there is no mean, if we cannot apply mean, then median is the second level to show the central tendency. In that case, we show the marginal maximum by showing the Q2 as median and Q1 and Q3 as the range. Understand? Can you please repeat the CI with 1.96 constant value? See, constant value comes from the table. That is the mathematics one. I'll not go there. Okay. And even I don't know that part. But how it comes is, it is like mean plus the standard error of mean. Understand? The confidence interval is the mean and standard of mean ka 1.96. 1.96 is attached constant here. Okay, and confidence interval, you don't have to understand the value here. You have to understand what is CI. CI is your confidence that you are assuming that your 95% of the values, your 95% of the population is falling in place with only less than 5% of the error. Okay. No, if the 90% CI, then Z value may change. Yes, then Z value may change. I'll tell that. Okay, that Z value will change if the 90%. Yes, if the 90% or 99%, then Z value also will change. Okay, in certain cases, it is for 95%. Okay, it is for 95%, guys. Okay. So let's take the off here, and I'll see you tomorrow. Guys, thank you very much, and I'll see you tomorrow. And I think we have the meeting of innovation team. You guys come, I'll be joining you in 2 minutes. Okay. Thank you guys. Take care.